Good day, students. Today I want to solve problem on centripetal acceleration involving circular track. The first thing to do is to look at the question to see whether there are mixtures of standard units and non-standard units, so that you convert the non-standard unit to a standard unit before you start solving your problem. Okay, centripetal acceleration. In the last class, I told us that we have an object moving in a circular path, and the object that is moving, let's assume this is a car. This is a car moving in a circular path. The force that keeps it to move around the circle without skipping away from the circular path is called centripetal force, and the centripetal force that's keeping it is taken as mv squared over r, and the mv squared, the v squared over r, is referred to as centripetal acceleration. Is that okay? The v squared here over r is referred to as centripetal acceleration, which is defined as the magnitude of the centripetal or radial acceleration as a kinematic parameters is defined as the ratio of the speed squared to the radius of the circular path. Okay, what do you mean by that? This is the radius from here to here, is the radius to this point, the center. When you square the velocity, you now divide it by the radius of the circular path. Is that clear? The force that keeps the object moving without skipping away is what we call centripetal force. And I told us there's another opposite force that is acting outward. We call it centrifugal force. Is the opposite of centripetal force. And when you solve it, you still apply the same formula, minus ft. When we see minus, we know that is centrifugal force, which is minus mv squared over r. Whatever you get, let me say when you get 2 Newton for the centripetal force, let me say you have 2 Newton, centrifugal force minus ft will be minus 2 Newton. See the same value, but opposite to the centripetal force. Okay, now let's analyze the question. And don't forget that centripetal acceleration is also directed to the center of the circle. Likewise, centripetal force. Now, A centripetal acceleration equals v squared over r, and we don't have that's what we are looking for, and we have the velocity, the speed given to us, v equals 92 kilometer per hour. It's not standard unit. You can see we have the standard unit here. We have to convert it. Don't forget that 92 kilometer, let's just raise it up, over 1 hour. Per is 1 hour, and 92 times this 92 times 1, there's 1 arbitrary 1 here, times 1 kilometer over 60 minutes. 60 minutes make 1 hour. And don't forget that 1000 meters make 1 kilometer. Now I have 92 times 1000 meters over, we convert this to 60 times 1 minute, because 60 times 1 will still give you 60. You have 92 times 1000 meters divided by 60 times 60 seconds. 60 seconds make 1 minute. Let's start our division. 0 cancels 0, 0 cancels 0, 2 here 3, 2 here 5, 2 here 3, 2 here 4. Let's mean the 1, 2 in 12, 6. When you multiply that, you have 46 times 5, 26, 30, 20, 23. That's 230 divided by 9. 3 times 3 is 9. 9 goes there 2, that goes in 23 2. Remainder 5, 950, 5. That's 9 times 5 is 45. Remainder 5, add the 0, 955, 9, remainder 555, approximate it to 6. That's in meter per seconds. That's our speed. Now come back to your formula. AC, don't forget that radius is given to us. Radius equals 29 meters. Okay, that's 29 meters. Now you have v squared, that's 25.56 squared divided by r, 29, which is 25.56 times 25.56. You multiply twice, divide by 29. When you do your multiplication, you have 653.3136 divided by 29. Now centripetal acceleration, when you do your division, you have 22.5 meter per second squared. The unit of cellular acceleration is also meter per second squared. Okay, please take note that when you are dealing with linear velocity, we refer to object moving in a straight line. But when you talk about centripetal force, centripetal acceleration, we are referring to object revolving around a circle. Please take note. Linear acceleration in a straight line, linear velocity in a straight line. But when you talk about centripetal acceleration or centripetal force, anything involves circular form, that deal with an object in a circular motion. Is that okay? This is the end of our class. Please subscribe to my channel so that I can have access to the latest video. Have a wonderful day.